Okay, welcome back, Precalculus. We're working on lesson 8.2 here, the second lesson of Unit 8, and here are just the objectives for the day. We're going to learn how to modify the domain and range of a rectangular equation when the time parameter changes in the parametric equation. We're going to learn how to calculate the angle between two vectors using something called the dot product, and we will decide if two vectors are parallel, perpendicular, or neither. Notice that I did not go over the warm-up. I'm trying to make this video a little bit shorter, so if you should stop and do the warm-up, but then check the answer key to see how you did. Otherwise, I'm just going to go through the examples in the lesson. So the first example here, it just says we're working with vectors. Little reminder, a vector is a quantity that has both magnitude, which is its length or size, and direction. So we have an arrow over here, right, which shows its magnitude. That's the length of the red segment right there. And then the direction is the arrow that indicates that it's going from A to B. Also, the order of these letters indicate that as well. We're going from point A to point B. So if I'm going to write that vector in component form, remember that's your horizontal component. Your x-coordinate goes on first, so we go from -3 to 4, which we're going to the right, so that's a +7, or mathematically, you could take 4 and subtract -3 and get 7. So my x component is 7, my horizontal component. And then my vertical component here, we're going from -2 to 1, right? So we're going up 3 units, which is +3, or 1 minus -2. So that is my vector in component form for vector AB. The magnitude is the length right here, right? So if we're trying to find the length of that segment, then all you're going to do is just a Pythagorean theorem, right? It's a right triangle. So it's 7 squared plus 3 squared, so that's a square root of 58. And if you want to get the decimal answer, you can do that, but you don't have to. You can leave it in exact form. But if you get the decimal answer, you should get 7.615. Okay, example 2. It's talking about position vectors alpha, which is 6, 1, and beta, which is -3, 5. Part A says first we're going to draw these vectors. So we're going to go from the origin to the right 6. So alpha goes to 6, 1, 2, 3, 4, 5, 6, up 1. So your vector is actually from the origin to here. So this is vector alpha. Beta goes -3, 1, 2, 3, 4, 5. So your beta vector, if you were to draw it, right? So it says draw alpha and beta. Those are my two vectors, alpha and beta. The resultant vector, alpha plus beta, well, you can calculate that, right, by just doing 6, 1 plus -3, 5. Oops, I don't know why I put the fraction bar there. Sorry. -3, 5, and that would just be 6 plus -3, which is 3, and 1 plus 5, which is 6. So 1, 2, 3, 1, 2, 3, 4, 5, 6. So here is my resultant vector, alpha plus beta. Now what might you notice? You might notice that here when we get to the end of alpha, I could then add beta to it. So it would be right here. And so alpha plus beta results in this green vector from here to here. Okay, moving on. The dot product. So it's important to read this part up here about the dot product. It says, you know, when you add or subtract vectors, you get another vector as a result, right? We just did that in the previous example. However, when you multiply vectors, you actually get something called the dot product. Sometimes we call it the scalar product, because when you multiply them, you only get one single numerical value, and we call that a scalar. So it's not a vector, it's either the scalar product, dot product, it's just one singular numerical value. So if we had vector A, which had an x component and a y component, and we had vector B, which had an x component and a y component, then if we were asking you to multiply those together or to find the dot or scalar product, then you would take the two x components, multiply them together, times the two y components, multiply them together, and take the sum of those two products. Simple enough, right? So let's try it down here. And also this formula is not on the formula sheet. So it's not on the formula sheet, so you have to remember what dot product is. Okay, so we're trying to find alpha plus times phi. We're just going to multiply the x portions of the vector, so it's 3 times -2, and we're going to add it to the y product of the y's, which is 2 times -4. So our final answer is -6 plus -8, or just -14. Okay, so why did we need to know how to find the dot product? Well, that's because it is in this formula, which will help us find the angle between two vectors. So you need to know the dot product because that's going to help you find the angle between two vectors. Now, this is given in your formula sheet, but I've rewritten it over here. This is how it is written in your formula sheet. I'm not going to go over the derivation of this dot product. You can look at that in your notes, and then you can ask your teacher questions if you have any questions about that. So in order to find the cosine between two vectors, remember A and B are representing vectors here, you would find the dot product between those two vectors, and then you would divide it by the magnitude of vector A times the magnitude of vector B. So remember, this absolute value symbol in vector terminology means magnitude, or the length of. And we just did that in an earlier example. So example 4 says find the angle between the two vectors in each set, and then determine if those vectors are parallel, perpendicular, or neither. So we're going to use this formula up here to determine the angle between the two vectors. So I have my vector A and I have my vector B. So cosine of the angle equals the dot product, so that's just 4 times -2, which is -8, plus, sorry, I don't have a plus sign there, plus -2 times 1, which is -2, multiplication sign there again, sorry, and then divided by the magnitude of vector A times the magnitude of vector B. So vector A, this is, remember, the x coordinate, the x length and the y length, so we're just doing Pythagorean theorem, so that's 16 plus 4, because 4 squared is 16, -2 squared is 4. And for this one, it's -2 squared, which is 4, plus 1 squared, which is 1. So when I simplify this, I get -10 divided by the square root of 20 times the square root of 5. Well, the square root of 20 times the square root of 5 is the square root of 100, and that's -10 divided by 10, which is -1. And you are either going to find that angle measure by taking the inverse cosine of -1, or you're going to remember that cosine of -1 is equal to pi units, but I want an angle measure instead of in degrees instead of radians, so that's going to be an angle of 180 degrees. Now, if you have an angle of 180 degrees, do you think that creates two vectors that are parallel, perpendicular, or neither? And hopefully you are saying to yourself that means these two vectors are parallel to each other, right? So you have one vector at 4, -2, another at -2, 1. If they have a 180 degree angle between them, that means they are parallel to each other. Okay, next we have our cosine of theta, and we're going to do the dot product, which is -3 plus -2, which is -5. I'm going to condense here a little bit faster. My magnitude of the first one is 3 squared, which is 9, plus -1 squared, which is 1, so 3 plus 9 is 10. And then I'm going to multiply that times 1 squared, which is 1, 2 squared, which is 4. So I get cosine of theta equals -5 over root 50. Well, if you want to simplify that, 50 is 25 times 2, so it's 5 root 2, so it would be -1 over root 2. Well, -1 over root 2 is a pi over 4, but it's negative, which means it has to be in the second or third quadrant, right? So what are we going to get? We're going to get a 3 pi over 4 for the angle measure, or we want to do, we want to do, just put it down here, degrees. So you can take the angle and say that's inverse cosine of -1 over root 2, which means I have an angle measure of 135 degrees. So I have an angle measure of 135 degrees, Is it parallel, perpendicular, or neither? Well, this angle is neither 180 degrees nor 90, so therefore it is a neither. So these two vectors are neither parallel nor perpendicular to each other. So we have a parallel, we have a neither. This one is probably going to be a what? My prediction is it's perpendicular, but let's see. So again, cosine of theta, we do our dot product, that's -6 plus 6, so instantly I can just stop because -6 plus 6, is 0, and 0 divided by anything is going to be 0. So what is the angle measure going to be if cosine equals equal to 0? Well, that's pi over 2, or 90 degrees, because we're doing degrees. And if it's 90 degrees, that does indeed mean that these two vectors are perpendicular to each other. Moving on, example 5. Okay, let's read it here. It says, a line L passes through points A, 0, 3, and B, 1, 0. The origin is at point O, and point R is at x and 3 minus 3x. The point R, 3x, 3 minus 3x is on line L, and OR is perpendicular to line L. So step number 1, it says to write down the vectors AB and write down the vectors OR. So AB, we're going to put that in component form, so we're going from 0 to 1, so that's a positive direction to the right 1, and then from 3 down to 0, so that's down 3, and then OR, well, O is at the origin, so vector OR is from 0 to up to x, and then from 0 to 3 minus 3x, so it's just x and 3 minus 3x. Now the next part says use the dot product to find the coordinate of R. Well, remember up here it says line L passes through these 2 points AB, and line L is perpendicular to OR. So remember in our previous example when we had an angle between two vectors at 90 degrees, then our numerator was equal to 0. So if two vectors are perpendicular, then their scalar product, which is this numerator, right, in the formula we just did on the previous example, the scalar product has to be 0. So that is saying that if we multiply vector A, B, and OR, then they must be equal to 0. So in order for these to be perpendicular, then AB times OR should equal 0. So let's do that. 1 times x, right, plus -3 times 3 minus 3x, and that should equal 0. So now we just have a basic algebra problem. Oops, sorry, minus 9 plus 9x equals 0. So what does x equal? X should equal 9/10. It doesn't ask for x, it asks us to find the coordinate of R. So my x coordinate is 9/10. To get the y coordinate, I have to do 3 minus 3 times 9/10. So that's 30/10 minus 27/10, because I'm getting a common denominator of 10. So R is equal to 9/10, 3/10. All right, example 6, moving on. It says find the measure of angle ABC given that point A is at 2, 1, point B is at 3, 4, and point C is at -1, 3. So I graphed those points over here down below, and I want to find the measure of this angle here in between. So in order to find the measure of the angle, remember we're going to have to use this formula up here. Cosine of this angle measure is equal to the dot product of A times B divided by the two vectors magnitude of A times magnitude of B. The question is, though, in this example, you need to kind of graph it so you can see where are the vectors. So we have this vector, BA, and then we have this vector, BC. So first you need to find what those vectors are, right? So I would say I want you to pause right now. Maybe we'll find the vectors together. I guess then you should pause and actually try to do the calculation on your own, and then unpause and see in the video if you got it right. But you know, if you're going from B to A, we're going to the left one, so it's -1, then we're going down 5, so it's -5. If you're going from B to C, you went left 4, so it's -4, and you went down 1, so it's -1. So there are my two vectors. Now I have to use these two vectors, plug them into this formula, So go ahead and pause and try it on your own. So did you get 64.654 degrees? If so, then you did it correctly. If not, then I would pause again, kind of look at this work right here, right? I just took the dot product, multiplying the x's and y's together, took the magnitudes, plugged into my calculator. That's what you should have gotten. All right, let's check out example 7. So a little different scenario here. So it says car 1 moves in a straight line according to the equation xy, where we have our starting point at 0, 12. So I put that up here, 0, 12. And then this is our velocity vector. So we're going right 5, right? So right 5 down 3, right 5 down 3, right 5 down 3. Car 2 moves in a straight line. They're starting at 14, 0, so they're starting here, and then they go right 1 up 3, right 1 up 3, right 1 up 3, etc. If they were to not collide. But here they collide, so it says they collide at point 15, 3. So find the angle between the paths of the car. So what are we trying to do? We're trying to find the angle between the paths of the car. Now notice over here I put the angle here between this red and this blue. Now why is the angle on this side as opposed to this angle over here? Well, you have to look at the angle where it's going in this direction. Car 2 was moving in this direction, car 1 was moving in this direction, so the angle between them is where the arrows are pointing. So we're looking specifically for this angle over here on the right hand side. So how can we get that angle? Well, remember, in order to get an angle, you need two vectors. Well, what are the vectors going to be? They're going to be from this intersection point going this direction, this intersection point going this direction. So in these two vector equations, what part are helping us establish what vectors we need to use? And hopefully you're saying to yourself, it's just my velocity vectors, right? If I go to the right 5 down 3, right 5 down 3, this velocity vector is just what we need. It's 5, negative 3. So that's for car 1. And then for car 2, right, I would go right 1 up 3, right 1 up 3. So here that would establish my right 1 up 3. So my velocity vectors are what I need in order to find the angle. So go ahead and pause, try to calculate the angle on your own, but really the trick, quote unquote trick, not really, but the difficulty here was just establishing what vectors am I actually using to find that angle. So pause, find the answer, and check it with me. Okay, did you get 102.529 degrees? Hopefully you did. If not, I would pause and have a look through and see where you made your mistake. Moving on. All right, for this last example, example 8, I don't think there's anything tricky in here. So I would say just pause and try all of this on your own and then read through the answer key after you're done and see if you got the answers correct. But definitely pause, try to comprehend and go through it all on your own and look at the answers when you're done. Okay, here are the answers. Part A was simple, just writing the two position vectors. Part B was finding D. There were several different ways you could have done that. So D was equal to 11, which I have put over here in the diagram, answered here. And then you had to find vector BD, which also wasn't challenging, hopefully. Write your vector equation. Well, since this is my vector to get from B to D, I go across 12 down 3, then that's just now your velocity vector to get from B to D. What would the value of lambda be at point B? Well, B is technically your starting point. If this were something in motion, but it's on its parallelogram, but that's where we're starting, so your lambda is 0 there, because that's my starting position there. Is point P 7, 5 on line L? Well, if you plug in the x value and the y value and go straight across, right, and set them equal, do we get the same lambdas? Yes, we do. So yes, point P is on line L. And finally, use the dot product to show that vector CP is perpendicular to vector BD. So I didn't put the P on here. The P is 7, 5, so it's here. So if I did this purple vector with the yellow vector up here, then are they perpendicular? So in order for those two vectors to be perpendicular, that means their dot product has to be equal to 0. So I had to find a vector for CP. Doesn't look like a P, two PDs. and find it, or we already had the vector of BD, and multiply them together for the dot product to see that yes, we got a 0, therefore yes, they are perpendicular to each other. And that's it. So get started with your homework. Of course, always ask your teacher if you have questions. Set up a time to Zoom in the morning if you can't get your question answered during class. We always want to help. Thanks. Bye.